Hello. So today we're going to be talking about trigonometric substitution. So the table you need to know is shown here. I'm going to show a quick way to memorize it. So let me share a quick story. The story is about a guy. He's a little short guy, small boy. It's actually me. And then there's this gorgeous lady over here. She got nice hair. She got a nice smile. And, I'm still single. So I try to shoot my shot, but I'm kind of introverted. I'm shy. I need to step up my game, right? I need that sass. I need that confidence, that boldness. You know what I'm saying? But, when I first look at her, some thoughts, some sentences, some sentences naturally come to my mind. And the very first one that comes to mind is, oh, she super cute. Bam. You take those three things, you're going to shoot your shot. Shoot your shot. Boom, bada bing, bada boom. Right? So I'm going to take those things. I'll show you how to memorize the tricks of too. Right? So once again, it was sass, sentences. Oh, she's super cute. Right? All right. So there's something you have to memorize, like the square roots. So we're going to do that. All right. It's either A or X or A. You might get it confused, but don't worry. One thing I really like is anime, right? So there's something that goes on a convention every year called Anime Expo, AX. Aha. Well, you have to memorize they're all squared, so they'll all be squared. And this is where the sass comes in, right? S is for subtract. Boom. A is for add. And the last S is for swap. All right, so we're going to do exactly that. We're going to do A squared plus X squared. Well, let's swap. Well, you swap the first case. That's what's going on. So we're going to get X squared minus A squared. We got the left-hand column. All right, the next thing you have to memorize is all of them have X equals A. So there we go. And next to the A is our trig. Well, sin sounds like sine theta. Tan sounds like tangent theta. And ses sounds like secant theta. Close enough. Finally, we're going to do O, which is opposite. Opposite of sine is cosine. That's what I like to think. S is for swap. So we're going to swap these. You get secant theta and tangent theta. And finally, we're going to square these. Square, right? Square them. Boom, boom, boom. Well, you have to memorize the identities. So we'll put them down here. You get 1 plus tangent squared theta. And then tangent squared theta is secant squared theta minus 1. And there you go. You have the trig subtable. Voila. All right, let's do a quick problem. I'm going to clear the board. So here's our integral. Our integral is 1 over x squared square root of x squared minus 1 dx. So looking at this problem, there's no formula for antiderivative. You can't do u sub. You can't do integration by parts. This is not partial fractions. So you have to use trig sub. And kind of the dead giveaway is the square root part. It's very familiar. If you look at the table, you get x squared minus a squared. All right, so you look at your table and the rest of it, you can jot it down. So you get a secant theta, and you jot down the identity, which is tangent squared theta equals secant squared theta minus 1. Right, so it's all from the table and should be from memory. From there, we're going to look at, notice how the 1 and the a squared, they're the same. Take the square root of both sides, you get 1. Plug in a into there, you get x equals secant theta. Right, so if our x's, we're going to find dx's by taking derivatives. So derivative secant theta is secant theta tangent theta d theta. Very nice. This is a substitution, so we're literally going to plug and chug into the integral. So x squared is on the bottom, so it becomes secant squared theta divided by secant squared theta minus 1, right? Because secant theta squared is x squared. Then dx is secant theta tangent theta d theta. All right, from here, we're going to use our identities. So our identity is right here. Where do we find our identities? We find it inside the square roots. So this is right there. So we're going to replace our secant squared theta minus 1 with tangent squared theta. Tangent squared theta. All right, so now we have this, and we can do some simplification. So the square root of tangent squared theta is actually just tangent theta, right? And now we're going to go fruit ninja. Boom, boom, boom. Right? The tangent thetas cancel out. One of the secant thetas cancel out. So you're left with the integral of 1 over secant theta d theta. Well, secant theta is actually 1 over cosine theta, 1 over cosine theta. 1 over cosine theta is just the same as integral cosine theta d theta. And integral cosine is sine theta. So sine theta. But since there's no bounds and this is an indefinite integral, we must put our plus c. All right. Now I need a little bit of room, so I will erase this. But we can't erase everything, so we don't need this. All right. What do we do here? You can't put that as your final answer. Your final answer should be in terms of x. Well, look it. We got x equals secant theta here. How convenient. So we're going to use that. Well, this is the same as x over 1. Secant theta, we know, is hypotenuse over adjacent. So there we go. Voila. I'm going to erase a little more so we have a little more space. From here, you're going to draw your triangle. Your triangle will be your best friend. So draw the triangle, put a theta on the side. All right, x goes on the hypotenuse, 1 goes on the adjacent. You need to find this question mark. So what we're going to use a squared plus b squared equals c squared, right? So it's going to be 1 squared plus question mark squared equals x squared. So you're going to get question mark squared equals x squared minus 1. Take the square root of both sides, you get square root of x squared minus 1. So that's our square root. To finish off this problem, we're going to do sine theta. Well, what's sine theta? Sine theta is opposite over hypotenuse. Opposite over hypotenuse. We know question mark was square root of x squared minus 1, and the hypotenuse is x. Put our plus c, and there we go. That is our final answer. So that's how we would do trig sum. Thank you.